Hello everyone, in this video we're going to focus on how to measure the variability of the data. Remember, again, I want to re-emphasize, from the beginning of this chapter I said, if somebody asks you, hey, summarizing your data for me, the goal is you need a statistic to measure the central location, you also need a statistic to measure variability, and also you need a statistic to measure the shape of distribution if it's a quantitative data. Okay, so now, after we finish learning the statistics measure the central location, you need to know that we don't need to share all mean, median, mode all the time. We need to find the most proper one, right? The same for the statistic that is measuring the variability or measuring the dispersion. You don't need to show everything. You need to pick the most appropriate one. And so in this part, we are covering many different kind of measures to measure variability, but you need to remember the most helpful one. Okay. So the variability, also called variation, also called dispersion. So it is measured the spread of the data points about the center of the distribution in the sample. Okay, if you think about after we understand measure the center, so you only showing one side of your data. Just thinking about when you draw a circle, right? So when your professor say, hey, draw a circle for me, use campus. So you're gonna ask, hey, what is the center? Where the center gonna locate it? And how wide, which is the radius of your circle, right? In order to draw that perfect circle. The same analogy we can apply here. After you know the center, which is where the data center lies at, you need to tell people how wide that radius look like, right? This is called a variability or variation. And we are considering a possible sample distribution of the study time spent by several college students taking the economic class. And so all three examples here, if we're going to calculate mean, they are approximately the same. So why there are three different samples? Because the variability are very different. On the first diagram here, the study hour per week, so that considered low variation. So they're all very centralized, close to 4. And then the middle one is called more variation compared with the first one, although the mean is still going to be 4. And the last one is called high variation. If we calculate the mean, still going to be 4. But as you can see, the last one, it's very spread out. Okay, so this example is telling you when somebody say, hey, summarize your data, if you only tell people the mean, it's not enough. You need to discuss the variability or dispersion. So here I want to show you what we're going to learn in this class related to the dispersion. We're going to focus on the range, sample variance, sample standard deviation, coefficient variation. And so on this page, I show you the Excel formula as well. And we'll work on the practice question, and we're going to look at how to do it by hand. And so the last one, the MAD, mean absolute deviation, we will cover a little bit, but that's not the one we're going to focus on. And we're going to focus on range, sample variance, sample standard deviation, coefficient variance. So some students say, hey, Dr. J, you said sample. Does that mean the population is not covered? So the reason on this table I'm showing you the sample, because later as we dive into each statistic, you need to know that many of the formula you see here for the Excel and also for the formula itself, the mathematical formula, the sample will be different from the population. Okay, the sample will be different from population. And before diving, talking about similar as we discussed for the mean, right? We need to look at the strength and the weakness. So what is the strength for range? So the range is very easy, everybody understand, easy to calculate it, easy to interpret it and share with the audience. However, the weakness is very similar as the mean, so it very easily be affected by our extremely large or extremely small value. Okay, then the second is called the sample variance or the variance. So this is play a key role in mathematical statistics. That means after people realize the range doesn't really work when we have extremely large and small value, people think about, hey, can we improve it? So the variance is the one we invented. The problem for the variance, as later we're going to go through this formula again, is it's really cannot interpret it. So due to the mathematical calculation, we are not able to interpret it directly. Okay, so therefore people make improvement based on the variance to create called the standard deviation. And so if you talk to people, standard deviation is the most popularly used measure to measure the variability. Nowadays, when you hear the news report, they always talk about standard deviation. So the standard deviation make up all the weakness from the range and sample variance. So it is a very common measure, and then it is the same measurement as your raw data. And so again, it's still very hard to interpret it. And then so therefore further down the road, we have to cover coefficient variation. So for this one is express relative variance in the percent. So it allows you to compare across different data. So to say, hey, which one has more variabilities? And so however, for this coefficient of variation, it requires non-negative data. So you want to make sure all your observations are positive. But as you know, it might not be the case. Sometimes you will get the negative values. So if that's the case, the coefficient of variation cannot be used. And then the last one is called the mean absolute deviation. So that is very easy to understand. But then the negativity is like nice theoretical properties. So in the daily work, I most seen is the sample standard deviation. And then occasionally I see the coefficient of variation. But in this class, we're going to cover everything. Okay. So first, starting from our range. Range is the most easy calculate statistic to measure variability, because what happens is you just need to go to your data space, your sample, to look for the extremely large, the larger value and the smallest value. So the differences between those two values give you the value called the range. Okay, so that is what this formula means. You find the the larger value minus the smallest value. That's going to give you the value of the range. Okay, so it is easy to calculate, but the negative part is it's only consider the two extreme data value, the largest and the smallest. So that will give you, you can imagine if we do have outlier, extremely small or extremely large value, the range value can be vary, right? So therefore this range is very sensitive to your extremely large or extremely small value. So therefore, when we think about rigorous statistical analysis, we usually don't use range, although we still report it, and you need to know the weakness of the range. Okay, next, called variance. As we're talking about the reason the range had a weakness because they only use two data points, right? The largest and the smallest. So the best way to fix it is let's use all the data. So how can we create the statistic that consider all of them, but measure the variability of the data? So here we want to introduce variance. Like I said, at the beginning of the video, I introduced called the sample variance. But here we dive into variance. We want to distinguish the sample variance from the population variance. Okay, first, the population variance. We are using a Greek letter. Remember, every time we're thinking about the population, we use a Greek letter. So the Greek letter here is called a sigma. Okay, this is called the sigma. So the sigma square representing the variance. Keep in mind, sigma squared. Don't forget about this little 2 here. If you forget about it, that'll become different statistic. Okay, sigma squared is the variance. So this is defined as the sum of the square deviation from the mean divided by the population size. Okay, think about what is variance, right? Variance measure the deviation from your sample mean, right? Deviation from your center. So based on this idea of variability, we're creating this these measures. So the x should be xi, not 1. So the xi minus mu. So the mu we already know that is the population mean. So each observation minus the mean. And then we square that difference. Why is that? Because you can imagine maybe the first value is the difference is positive and the second observation is negative. So when you are summing those different together, if you have positive and negative value, they're going to cancel each other, right? So we don't want that to happen. So therefore, we're going to square that difference to make sure my difference is always going to be positive, right? So that's why we need this square. And I will sum all those, called the sum of the squared differences together, and then divide by the population size. So that gave me called the population variance. Okay, so for the sample variance, it's a little bit different. So for the sample variance, we are using each observation minus my sample mean. Okay, so numerator are still the same as my population. But on the denominator, instead of divide by n, we divide by n minus 1. Okay, so this is really to call the degree of freedom. The reason is that we already using my sample data to estimate X bar already, so they lose 1 degree of freedom. So therefore, we need to use n minus 1 instead of n. So in terms of degree of freedom, we can talk a lot. So, but here you just need to remember that first, when we look at the population versus sample variance, they not only just notation differences. Okay, one is a sigma square, one is s square. The most important part is the formula itself is no longer the same, because one is divided by n, the other one is divided by n minus 1. So therefore, when we learn Excel at the end of this, after this lecture, and you will notice that I'm introducing two formulas. One is for sample and one for population, because they literally will get different answers. So then you're going to ask me, hey, Dr. J, how do I know when I use which formula? Because they give me different answers, right? So first of all, read the question carefully. If it is set it will let you know whether it's population or not. If it doesn't say it's population, by default, we consider all the data set work on in this class will be the sample data, because we have no luxury to get the population data. Okay, unless the question telling you, hey, this is the population data. Okay, if it doesn't say population data, and you just assume that's a sample data. Okay, so this is the variance. Before we move on to the standard deviation, let's look at the example together. Okay, so let's look at this example here. Okay, so let's say the example here is a 1, 2, 3, 4, 5. Okay, so I don't want to make it easier. Okay, so first I'm just gonna treat this as my sample data, and like I said, population, you just make sure you divide by n minus 1. So we had the 5 observations. I need, in order to calculate the sample variance, I always need to get my sample mean first. My sample mean equal to 1 plus 2 plus 3 plus 4 plus 5, and then divide by, I have 5 observation. So therefore my numerator here is 15, right? I got 15 on the top, divided by 5. So my sample mean is 3. Now I need to calculate standard deviation, variance. So the variance here equal to summation of xi minus x bar squared divided by n minus 1, since it's the sample variance, n minus 1. Okay, so now I'm gonna expand in the top. So like I said, this summation means you use observation minus sample mean and then square, and then move on to the next observation minus mean square, and then add all those square difference together. Okay, so the first observation is 1 minus 3 square, and then plus 2 minus 3 square, right? 2 minus 3, the next one is 3, right? Plus 3 minus 3 square plus 4 minus 3 square plus 5 minus 3 square, and then divide by, I have 5 observation and 5 minus 1. Okay, now the numerator here, 1 minus 3 equal to negative 2. Negative 2 square give me 4, and 2 minus 3 equal to 1. Negative 1 square give me 1. 0, 1, and 4. Divide by 4. So therefore my numerator equal to 10 minus 4 and give me 2.5. Okay, this is my sample variance. So now you're gonna ask me, Dr. J, how you interpret it. The answer is, the interpretation will be the variance of 2.5. I really cannot interpret it, because as you are squaring your unit, the differences, you change the measurement unit, right? Let's assume that before is the price, $1, $2, $3, $4, $5. Once you square that dollar squared doesn't mean anything anymore, right? So therefore, the S squared, the variance itself, really hard to interpret it, because you change your original measurement unit. Okay, but anyway, so this is how you are able to use the formula to calculate the variance. Now, since we know the variance is really hard to interpret and rarely used, and one of the main reason is because the measurement unit change after you square the differences. So therefore, we have a way to fix it. That is taking that positive square root of your variance. Therefore, we came up with the idea called the standard deviation. So standard deviation equal to the square root of your variance. And so we want to make our notation easy to remember. Therefore, without that 2, and then that we are consider that is my standard deviation. So the sigma itself representing the standard deviation for the population, and the S itself representing the standard deviation for the sample. Okay, so again, by doing this positive square root, allow us to make sure the variability is measured under the same unit as your original data. And so in describing variability, we most often use the standard deviation, and the standard deviation is a single number that help us understand how individual value in the data set vary from the mean. Okay. Okay, so therefore, this is the most popular standard deviation you need to use to measure the variability. Okay, variability. Now let's look at how can we converting my variance to the standard deviation. Look at the example we just worked on here. Okay, so this is the sample variance. Now we want to calculate the sample standard deviation. I just need to take the positive square root of what I just got. Okay, so then I will get so it's going to be approximately equal to 1.58, right? Let's see. Yes, it's very close to 1.58. So it's in infinite decimal places. So if I keep 2 decimal places equal to 1.58. So now I can interpret it, right? So basically, if they all measure by dollars, so $1, $2, $3, so the mean of my sample is equal to $3, and the standard deviation is $1.58. Now I am able to interpret it. Okay, so this is the standard deviation. The next we're going to look at is how about we want to compare different data sets. So let's say you have a data set about the dollar you spend buying houses. The other is the weight you fluctuate for the last month. You want to ask, hey, for these two samples, which one had more higher variability? So you want to compare variability. If that's the case, the two data have different kind of measures, and the best way to do is using the next method is called coefficient variation. But before we move on, that I'm missing one thing is about the standard deviation used to compare risk. Okay, so I know a lot of my students are finance major, and so in the financial world, we talk about, hey, what's the risk of my stock? What's the return? What's the risk for investing? So that means the uncertainty of the stock, and usually we use standard deviation to measure the risk. So therefore, if you talk to the professional, you work for the financial area, when people ask you about the risk, so most common thing we're going to do is just calculating this standard deviation, and we use the standard deviation to consider whether the stock is volatile or not. Okay. Like I said, we move on to the third measurement to measure the variability called the coefficient variation. We will use this called the CV when we are trying to compare data set that have different measures. Like I said, what is the variability of your daily weight changes versus the variability of your spending on the house, buying different kind of houses. So that two very different data set, but somehow you want to compare which one have high variability. That is when you want to use CV, coefficient of variation. So for CV, we don't have the Excel formula directly available to calculate. Basically, you will calculate based on the formula I'm showing you on this PowerPoint. So we are using S, with your standard deviation, divided by the sample size, the sample mean, and the times 100. So the CV is measured as a percentage number. So the CV is the standard deviation expressed at the percent of the mean. So the way we interpret it is that the standard deviation can express the mean, so the CV can exceed 100%. So this can happen in the school data set, especially if there are outliers. So when you interpreting CV, you should think about that. The larger the CV, the higher variation. Okay, so if, for instance, you compare the weight, your weight changes daily. Let's say your CV is 2%, but your house spending is 200%. So in that scenario, your house spending have much larger variation than the daily weight changes. So that also means the house spending has a higher risk than your daily weight changes. Okay, so after we see this formula, of course, if you're dealing with the population data, you just need to make sure the numerator here is sigma, is your population standard deviation, and the denominator is the population mean. Okay, let's look at the example together, see how we calculate. We use the same example here, right? We already calculate the mean, right? So the mean is here, and then the standard deviation is here. So therefore, the CV is equal to 100 times S divided by S bar. So it will be 100 times 1.58 divided by 3. Okay, 1.58 divided by 3 times 100 equal to 52.67%. Okay, so therefore the 52.67% of variation is in relation to the mean. So again, smaller than 100% still consider low risk. Actually, this is low risk. Once it's above 100%, it will be considered high risk. But this is how you are able to calculate the CV by hand. Later, we're going to use Excel, and I'm going to use Excel to teach you how to do the calculation. Okay. So the last statistic you can use to measure the variability is called MAT, mean absolute deviation. And so the formula itself is very similar as we saw before, except you can see instead of square the differences, we actually find the absolute value of your differences, and then sum all those absolute value together and then divide by n. That will give you the mean absolute deviation. So the absolute value must be used, otherwise the deviation around the mean can sum to 0, right? So the MAT is appealing because of the simple, concrete interpretation. And using the lever analogy, the MAT tells us what the average distance is from the individual data point to the center. Okay, so before we look at the practice question, let's look at the whiteboard together. So for this example, again, in order to calculate MAT, okay, just find this corner. So see, this corner might have some space. So to calculate MAT, what I'm going to do is using each observation minus the mean, but I'm going to use the absolute value and then divide by the sample size. I think it's divide by n. So regardless what you're doing, so divide by n. Okay, so then what I'm going to do instead of square here, I'm going to use 1 minus 3 and absolute value plus 2 minus 3 absolute value plus 3 minus 3 absolute value plus 4 minus 3 absolute value plus 5 minus 3 absolute value, and then divided by 5. Okay, no n minus 1. And then the numerator here, 1 minus 3 equal to negative 2. The absolute value will be 2. And then negative 1 become 1, 0, 1, 2. Divided by 5. And my numerator equal to 6 divided by 5 and equal to 1.25. Okay, so that is using, 1.2, no 5. 6 divided by 5 equal to 1.2. So if I'm using the MAT to calculate the standard variability for this data set, I got 1.2. And so 1.2 is still measured under the same unit. If 1, 2, 3, 4, 5 is measured by dollar, so this 1.2 also measured as a dollar. Okay. Okay, after we learn the different kind of statistical measures, and then we can work on a practice question together. Okay, so this question also relates to your homework. So first, we have 3 data sets, A, B, and the C. We find the mean, and then find the standard deviation, treating the data as a sample, and then finding the standard deviation, treating the data as population. And hopefully, we also want to practice calculating CV as well. What does this exercise show about the two formulas? So basically, what's the mean difference between the sample and the population? Standard deviation, like I mentioned, the mean are exactly the same, right? But when we calculate standard deviation, really depends on sample population. You will use different kind of formula. So let's look at together on the whiteboard. Okay, so first let's calculate the mean. Okay, for the we treat it first, regardless it's mu or x bar, the formula are the same, so they will get the same answer. So we can see mu equal to mu. So this is for A, right? So we will get 6 plus 7 plus 8 divided by 3. So that gives me 6 plus 7 plus 8 equal to divided by 3. So that gives me 7, right? And the B, the same. So regardless how we consider it, so 4, 5, 6, 7, 8, 9, and 10. And then divided by 1, 2, 3, 4, 5, 6, 7. Right, 1, 7. So 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So that's gonna give me, the numerator is 49 divided by 7, that give me 7. And the C, 1 plus 2 plus 3 plus 4 plus the rest of the number plus 11 plus 12 plus 13. And we total have 13 numbers. Okay, so again, I just don't want to write all number. You need to know that we're just adding all the number together. And then my numerator here is equal to, let's see, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13. So numerator equal to 91 divided by 13. And again, it gave me 7 again. So all three data set mean are exactly the same, equal to 7. Now let's look at the sample standard deviation. Okay, so first we treat the data as sample. So if it's the treat as a sample, the formula we're using, S will be equal to positive square root x summation of x I minus x bar square divided by minus 1. Okay, so this is going to be the formula we use. So after we apply, so first I'm going to use A as example, and then for the rest, for the sake of the time, I will just very quickly calculate behind this video, and I just show you the answer. Okay, so my numerator, so 1 will be 6 minus 7 square plus 7 minus 7 square plus 8 minus 7 square divided by 3 minus 1, right? Take positive square root, so that will give me the positive square root of, this is 1 plus 0 plus 1 divided by 2, so this is going to give me 1. Okay, so A is 1. Like I said, I will save everybody some time here. I will do under the video to finish the rest. And then I calculate the sample standard deviation for B is 2.16. And for C is 3.89. As you can see, all three data sets have the exact same mean because the data does vary more in the C because they have more data, so you can see more variation. So the last one had a high frequency. Okay, so this is for sample. And then now let's look at if they are the population. And I will use A as example, and then I will do the rest calculation under the behind the video, and so I can save you some time. So if we're calculating as the population, the formula will have slight change, right? Instead of divide by n minus 1, we are using xi and minus mu square, but here we'll divide by the sample size itself. So in that situation, the A will become 6 minus 7 square plus 7 minus 7 square plus A minus 7 square. Instead of divide by 3 minus 1, we divide by 3. And then square here, right? So that will become equal to, the numerator here will be, let's see, 2 divided by 3 instead of 2 divided by 2. And then that will give us our square root of the 2 divided by 3. That will give us, so that will give us the approximately equal to 1.73. Okay. And I use the same method. I calculate the B and the C. So for B, my value is, let's see, what did I get? Okay, B, I got, let's see, B here is 2 for the population. And then C here, I got 3.74. Okay. So these are the answer for A, B, and the C if we consider data as population. Okay, so as you see for the, if it's a population, the value gonna be always larger than the sample, right? You can see the variation always kind of turn to be larger because if the A was 1, he'll become 1.73 for the population, and then B 2.16, and then here become 2, and here's a yes, a 3.89, and then it becomes 3.74. I can't say always larger. I should say the differences as you increase in the sample size between the population and the sample standard deviation, they get smaller, right? You can see initially the difference is 0.73, and then it become 0.7, about 7, the 7.3, still 7, no, 9.83. And then we become yeah, when we have very large sample size, you can see these two are getting close, right? 0.15. This is what we want to get out of this exercise. So the purpose of this exercise is want to show you that as the sample size increase, the population standard deviation and the sample standard deviation, they will really approaching to each other. So their value will get very close. Okay, so that's the main goal for this exercise. So in next video, I'm going to show you is how you are able to use Excel to calculating the standard deviation, variance, range, and the CVs using the computer Excel instead of by hand.